Does sample rate even matter? This is an interesting conversation, but my first instinct to answer is not really. Sure, 48K is what you want for video, but if you record at 44:1, it really isn't an issue unless you're syncing up a really long video. However, these aren't the only sample rates, so let's find out. And yes, the higher sample rates do come into play, but we're going to address that a bit later. Now, for the sake of this video, we're going to start out with the most common sample rate for anyone recording just voice, and it is this: 48K or 48,000 samples per second. Now, the reason it is the most common is because of video. This sample rate perfectly syncs up with all frame rates in video, and that is just simply because it offers whole numbers of samples per frame. And voila, if you want to know, here's the math to back that up. You see, if you use 44.1, that 0.1 there causes fractions to come into play, meaning at 24 frames per second, you end up with 1834.5 samples per frame. That half sample does start to add up relatively quickly, and you end up with the drift over a period of time, meaning your audio and your video get out of sync. But 48K is indistinguishable from 44.1 on voice when you're listening. And while a lot of people say they can tell the difference between 48K and 44.1, I'm calling BS. And I'm going to break out some information that proves it. So this might seem like kind of a random number thrown out there for a sample rate, but it actually has a very good reason for it. But to understand that, you need to understand something called the Nyquist-Shannon sampling theorem. But to understand that, you need to understand discrete time and continuous time. Now, I know this sounds complicated, but it's not. Continuous time is basically just analog audio. We all know those familiar waves. Discrete time is basically digital audio, or the recreation of continuous time with a specific amount of samples, or sample rate, if you will. Now, what the Nyquist-Shannon sampling theorem stated was that to recreate the most natural sound of continuous time, you need to double the amount of samples to the signal's bandwidth. And yeah, I can see a lot of you guys sitting there like, don't worry though, the hard part's over. So you see, the frequency response of human hearing maxes out at 20,000 hertz, right? So to recreate that, you will want at least 40,000 samples of it. Double. Now, the 44.1 sample rate was chosen because it also offers a bit of headroom, a term all audio people love, which is why our brains do not distinguish differences between 44.1 and 48K, because as far as our brains are concerned, 44.1 has completely rebuilt that waveform. Okay, so now we're testing out the under 40,000 samples from that Nyquist-Shannon sampling theorem. And this here is being recorded at 32,000 samples per second. And if I switch between it and 44.1, your brain should notice just a slight difference. There are some frequencies probably missing to your ear. Honestly, though, this might not be a massive difference depending on how your ears perceive it, but I can guarantee you that it should just sound off to everyone, as your brain will notice the difference even though it can't quite put its finger on the problem. And in case you want to hear the difference between 32,000 samples and 44.1, this is 32,000 samples per second, and this is 44.1. And again, this is 32,000 samples per second. And this again is 44.1, or 44,100 samples per second. Okay then, let's take it down a little bit more. We're somewhat splitting the difference down to 22,050, and you should really notice a difference now. And honestly, this is just not having enough source information to recreate that original sound wave that went into the microphone. And it's kind of interesting how it's lopping off the highs quite liberally. And as we get even lower, this is down to 16,000 samples per second, and it just gets worse and worse. Again, this is why that recreation of an analog waveform needs 40,000 samples per second. And now that we're down to 8,000 samples per second, the audio just seems to be getting worse and worse. What do you think of this? There's still one more step to go, though. And finally, we're down to 6,000 samples per second. And this, not gonna lie, is becoming rather unlistenable. So with that in mind, Let's ramp those samples back up, why don't we? So then why do producers work with higher sample rates when they're doing music and such? I mean, if 40,000 samples recreates the waveform perfectly for the human brain, what is the point? Well, it's interesting because even at 44.1 or even 48, using that sample system, it's never actually perfectly recreating the analog wave. So there might be some stuff missing when you digitize an analog sound. This is why producers work with the highest quality audio when they produce, and then they export it out at CD quality. It's kind of like a camera shooting at an oversampled 6K, but then giving you a 4K image. Just kind of a way of limiting what might be cut out. But can you hear the difference between 96K and 48K in voice? If you can, and I'm calling BS, I've been changing the sample rate throughout this last chapter. If you can hear the differences, all you have to do is tell me how many times I changed from 48K to 96. Let me know down below. Curious to see if anybody can get it. And if you want to see other things broken down like this again, let me know down in the comments. I think bitrate is up next. Cheers, guys, and thanks for watching.